I forgot to already load in this page so that I wouldn't just magically appear. Oops. Alright, well, hi everybody. So, subtraction is hard to prove. I'm still working on it. And I don't necessarily know when I'll be able to prove it all for myself. What's up, Hunted? How you doing? Subtraction. Because subtraction has some pretty weird rules when you really think about it. Like, 3 minus 2 is not the same thing as 2 minus 3. But for addition and multiplication, you can swap the numbers around that symbol, and it still works. So how do you prove that that's how subtraction works from base principles? So I've been able to do that for addition and multiplication, but subtraction is weird. Namely because subtraction is how you discover that there are numbers that you can't count on your fingers. So, namely, negative numbers. So, we started by defining what the counting numbers were. They were just sets, or suitcases, and the number 0 was a suitcase with nothing in it. Yeah, essentially. Like, the Indians, like 2,000 years ago, were the first ones to actually assert that nothing was something. Like, they didn't just give 0. Oh, when I say Indians, I mean, like, actual from India Indians. Like, even 20 years ago, I always kind of cringed whenever I heard people refer to Native Americans as Indians, because it's like, but that's not what they are, because Columbus was wrong. He didn't reach the Indies, so the people that he made contact with were not Indians. So why keep using a wrong classification? Okay, stupid tangent. I'm gonna stop that. But yeah, like, ancient Indian mathematicians were the first ones to actually assert 0 is a thing. Exactly. But yeah, so the ancient Indian mathematicians were the first to say, okay, for thousands of years, yeah. They invented the concept of 0. An Italian mathematician in the mid-1800s, I don't remember his first name, but his last name was Peano, created a list of foundational statements that you can use to create mathematics as they knew it back 150 years ago, just from logic and set theory. So they showed that, like, mathematics itself is not a fundamental thing. So it's kind of like how atoms are not the fundamental building blocks of matter. You got stuff that make atoms. So, like, protons, neutrons, electrons. And then you find out that protons and neutrons are not fundamental things. They're made up of other things that are more fundamental. So it's the same thing with math. Peano essentially showed that sets and logic are like the protons and neutrons for numbers. And then from there you can build up all the rules for addition, subtraction, because that works on all of the natural numbers. But, addition and multiplication. Subtraction is where everything goes out the window. Because if I said, hey, what's 2 minus 3? The answer is not a natural number anymore. Yes! Like, that's my whole thing. Like, I'm not just waiting for people who have, like, homework questions to ask. If there's, like, a topic that you want to talk about or have explained, and it's something that I know about. Because if it's not something that I know, then I'm not really going to have me talk about it. I might have whoever's in the chat talk about it, but, like, yeah. So, like, if you're gonna ask, hey, can you prove Fermat's last theorem? I'm gonna be like, no, because I haven't read the 1998 paper. But, like, if there's another thing, like, I don't know, like a subject that's in linear algebra or differential equations or something, then I can talk about that, yeah. So you don't have to have, like, you don't have to be, like, an actual math student to ask anything. You can ask whatever. And if it's something that I know, then I'll say something, and then if it's not, then I'll just cry. Because it just realizes that I'm a charlatan, a sham. Yeah, I'm not a real math person. I think you were the one that came in here and started talking about hash functions, weren't you? Yeah, see, you know enough for me to look like an idiot, so... And salt. I am not against smoking of the marijuanas. And also, I'm completely for the decriminalization of it, and also releasing the tons of Black and Hispanic people that were wrongfully imprisoned for possession of marijuana. Like, releasing them even when they were arrested while the laws made marijuana possession illegal, because they weren't really doing anything wrong. And funny enough, I'm pretty sure the laws were made specifically targeting Blacks and Hispanics, so that they could just lock them up. Which is systemic racism. Yay! Shoot. Oh, yeah. Yeah, and see, that's what I'm trying to do with, like, math from scratch. It's like, you're given, as a student, you're given all this math stuff, and you're like, okay, a negative number times a negative number is a positive number. And you're like, okay, cool, remembered it, got it. And then you're able to kind of work your way from there, but I realized, at least for me, I accepted a lot of these math identities and rules almost like somebody accepting something out of faith. Nope, never heard of that one. So you'd have to tell me about it. So yeah, I'm still working on rebuilding subtraction from scratch. But I mean, it's already been done. Like, the piano stuff and everything after that, I think is just called axiomatic set theory of mathematics. And so people have, you know, over 100 years ago, reproven everything. At least as much as you can using that method. I'm just trying to do it for myself, and then showing other people, hey, this math stuff actually has, like, a reason for why it does what it does. You don't just have to, like, trust when people say, oh, well, you know, 1 plus 2 is 3. You can actually, like, prove that for some reason. Yeah. So, I'm not going to talk about subtraction today. Matter of fact, I don't know if I'll talk about subtraction tomorrow or the day after that. So I gotta figure out some other stuff. What I did think about doing today is proving something that's actually from trigonometry. It's something that I proved, dang, maybe even a couple months ago. But, like, I had, like, one follower, and I don't think they watched me talk about that. So I'm going to prove the triangle identity in trigonometry. And now you're going to hear me read a massive explanation, so here I go. Okay, so here's the wizard standoff riddle. You've been chosen as a champion. Whoa! Hey, don't post it so quick, I gotta read it too. Because I want to read it out loud, because I might as well. Because you show me interesting stuff, so yeah. You've been chosen as a champion to represent your wizarding house in a deadly duel against two rival magic schools. So it's a Harry Potter-inspired thing, but it's probably an older problem than from then. Your opponents are fearsome. From the Newts and his school, a powerful sorcerer wields a wand that can turn people into fish. But his spell only works 70% of the time, and from the Leibton school... okay, Newton and Leibniz, got it. Because that's Leibniz. Oh, it's still Newton and Leibniz, gotcha. Well, hello, Shadow! How are you? Okay. My memory is atrocious. I know your name. I know that you followed fairly recently. Matter of fact, I could just scroll down. Yeah, you followed about a week ago. Did you follow for Silent Hill, or did you follow for math, or did you follow for both? Or did you follow to listen to my sultry voice? Or did you follow because you felt sorry for me, because I feel sorry for myself? But I mean, I remember talking to you. I am just very dumb. I'm like that substitute teacher. Wait. Oh, wait, no, you're Floy Floy! Right! Yes. Oh. And I mean, yes. Although I've never seen you, but you don't have to show pictures, because I like people preserving their anonymity. That is nice. Solve this riddle. Well, now you got me really intrigued, because it's like, with the names, it's implying that it's something from the the Newton-Leibniz era of the, like, 1670s, 80s. When calculus was finally getting proven. Also, I forgot how to say goodnight in German. I'm pretty sure night is either Nacht or nicht, but I don't know. And I'm pretty sure good is... Okay, so it's gute Nacht. Do you pronounce the E? Or in German, are there letters that you don't pronounce like in English? Like, if you say the word flute, the musical instrument, you know, the E at the very end just makes the U a long U, but you don't say the E. You don't say flute or fluty. So this is the same. Is it the same with G-U-T-E? Is it just gut, or is it gute? Like, do you have to put an at the end? Also, I love my intro music, but I don't love it enough to listen to it for 20 minutes, and I apologize. So let's go to my main room so we can listen to something else. Okay. So it's Gute. Yeah? Yeah? Not gut, but Gute? Or is it gut? Like, how do you pronounce E in German? Is it just or is it eh? Yeah, but that's where you get all the really cool compound words. Especially in physics and mathematics. Like, one of my favorite German words is eigenfunction, which literally just means self-function. And you learn about that in linear algebra. But yeah. I think that German is a little sus. So here you go, pronunciation. German vowels. Long and short E. The short German E vowel. The short German E sound is articulated in much the same manner as the E vowel in English. So it is an E. It represents the same sound, therefore, as the short German A with... Is that the sideways colon? I think that's called an umlaut, but I don't remember. Also, I didn't know the German A with a colon on the top was an eh. That's interesting. Huh. But yeah. Gute Nacht. But yeah. Okay, so let's look at the wizard Rizzle puddle. Riddle. Okay, so I did say it right. Gute Nacht. So, like, the eh at the end is subtle. Like, you don't go Gute Nacht. You know, you don't put the emphasis on that syllable. So it's almost like in French where, like, you do say a vowel, but you say it so softly that it kind of just merges with the word coming after it. Also, how dare you get me off track and thinking about linguistics and not, math. Don't be scared that I compared you to the French. You're both, well... Now I wonder. See, this is my ADHD brain at work. Here it goes. The riddles... Fuck. I am not going to surrender. Dude, we're all Homo sapiens, and that's the only thing that really should matter. So, shut up. Okay, back to the riddle. So this one house has a wand that turns you into fish. Okay. So, back to the start. Also, I'm not ignoring you, even though I am ignoring you. Good! I don't want you to shut up. I like it when you talk. But I am going to ignore you a little bit. Otherwise, I'm never going to get anything done. Okay. Woo! Okay, here we go. Newton's school power sorcerer wields the one that can turn people into fish. But a spell only works 70% of the time. And from the Leipzig school, an even more powerful enchantress wields the one that turns people into statues. It works 90% of the time. Okay, so... Let me pull up... Okay, I already have my paint program pulled up, so let me just kind of actually write down notes. So you got Newton is... They have the fish wand. And it is 70% effective. And then you have the Leibton. They have a statue wand. Oh, I believe you. So 90% effective. Okay, got that. Lots are drawn, and you're chosen to cast the first spell in the duel. Wait, hold on. You've been chosen as the champion to represent your wizarding house in a deadly duel against two magic rivals. Okay, so it's not Newtonids versus Lipton. It's you versus one or you versus the other. Okay. So, cast the first spell in the duel. The Newtonids Magician will go second, and the Lipton Enchantress third. After which, you'll repeat casting in that order until only one of you is left. But who targets who? I'm not... Is it like you cast a spell and it's going to affect everyone else? Usually when you use the word duel, it means just two people. Ah, okay. So you're targeting just one person, but it's up to you to choose who you target. Okay. Yeah. But you can't affect two people at once. Alright. The rules of the duel are strict, and anyone who casts out of order will immediately be out of the game. And if everyone is still... and if everyone's still standing at the end of the first round, you'll all be turned into cats. So you need at least one person to be turned into something. Alright. You get to choose one of 3 wands. Keep in mind that you get to go first. The wands differ in what type of spell they cast, and the percentage of success you can expect. You know that your opponents really want to win, and they're going to strategize, knowing their expected outcomes. Oh. So what's, what are the other wands? Yeah. But it just looks like the last part, just saying what kind of wands there are. Yeah. Choose your weapon! Well, what's my weapon? I said choose! Okay, I choose their weapon. So I solved the riddle. Haha. Okay. So it goes me, Newt, and then Lib. Boop, 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 boop. And we absolutely do not want to be turned into cats. So we do not want anyone to have to go after Leibniz. Because if none of us are transformed, then we're poop out of luck. Okay. So you must choose a wand. Your Wizarding House presents you with 3 options. The Banakar, which binds one target with vines and casts effectively 60% of the time. The Gaussian, which turns one target into a tree and works 80% of the time. And the incredibly rare Noether 9000, which banishes one target to a distant mountaintop and casts perfectly 100% of the time. Your opponents are masters of strategy as well as sorcery, and you know they'll make the choices that maximize... What's up, cat? Scientists develop methods that will allow lab animals to breathe from their rectum. I can believe it. Oh. It's possible that I didn't give everybody, like, you or Brandon enough powers. Maybe. I don't know. All I did was just hit -mod and then typed a name. But Cat's a real person. Like, they're an actual follower. Unless you're talking about a message that you typed and you want to delete, but I don't know. Hmm. Okay, so one thing that I don't understand, that, noter, and I realize that's noter, so Emmy noter, the Schnikes, what did... I want to say she's the one that came up with the, like, conservation law in mathematics, which proves that if you have symmetry in a certain kind of physics thing, then you know you also have an energy conservation law. Or at least not an energy conservation, but just some sort of conservation law. Wir uns unter einer Brücke küssen. Ooh. You better be careful what you say, because I believe Cat can understand what you're saying. I think. Maybe. Oh, no, I know. I know. Yeah, I just realized that, like, my brain didn't recognize Emmy Noter's name. I was like, Nother, who's that? And then I was like, wait, no, I know who that is. No, I know. The thing is, with that, Noter 9000 wand... Okay. So all you need to do is just to turn somebody else... You need a wand to work. You just need something to happen to somebody else. Okay, I guess either I skipped the win condition, or it wasn't posted. So I guess the win condition is... you're the only one standing. Because I was thinking with the Noter 9000, it's like... it'll instantly knock out somebody. So it at least guarantees that you'll go to the second round. So you won't be turned into cats. Yeah, that sounds like a good, like, probability and stats problem. And also, it sounds like this is game theory, too. I haven't heard of it. But it sounds pretty cool. I'll look into it. And yeah, there's a lot of thinking that would have to go into figuring it out. Which it means it's not something that I can do on stream, because I have to also talk. And I cannot think and talk at the same time. Oh, thank you. Yeah. Ah. Yeah, well, I'll definitely look into that. That might actually be a fun... if I can figure it out. Or at least find a way to express the solution in my own words. Then I might even talk about it in a stream. But yeah, that's pretty cool. It also shows that mathematics is more than, like, computation. Or arithmetic. Stuff like that. These players are smart, right? So you will be the biggest threat, and therefore the first target. Yeah, but you go first. That's the thing. It says, you go first. So it's like, you're not, like... I know. Yeah. So don't tell me how to solve it. I'll work on figuring it out without reading more on it. Also, my glasses keep falling down my nose, and it makes my eyes look like they're closing and I'm falling asleep. Like, my eyes are wide open. Okay, I push them back up my nose. Yeah, Shadow, I think you said you also know a little bit of Russian, too. Diagramming the wizard riddle. Maybe. Okay. Now, to actually, keep with my promise of proving the, trig, identity, the triangle identity in trigonometry. So the identity I'm talking about is this one. Sine squared of some angle, or some variable, plus cosine squared of that same variable equals 1. No, Shadow said he knew a little bit of Russian. No, I was actually just talking to myself. None of you guys actually exist. You're literally advanced chatbots. And that's what I'm going to believe till the day I die. Which makes me wonder, if I asked you guys to fart, would you do it? Like, hey Alexa, fart. But yeah. So this is like one of the earliest, interesting identities that you learn in trigonometry. Of course, you're told what the basic trig functions are. Like, what the heck is sine and cosine? They're defined. So, the sine of some angle, if I drew a right triangle, so... and I said one of these angles is theta, here's my right angle, then with reference to theta, this would be the opposite side. I'll give it the variable y. This side right here is the adjacent side. I'll give it the variable x. So y would be opposite of theta. Theta. This would be adjacent to theta. And then I'll just call this side the h, which is the hypotenuse. You might do a little more than fart. I mean, as long as you have the change of clothes, I guess that's okay? Just don't do it in, like, public where other people would have to clean up after you, because that sucks. I've been in jobs where I had to do that. It's not fun. So, the trig functions literally are just ratios of sides of right triangles. So sine of theta would be the opposite leg length, so what the variable y number would be, divided by the hypotenuse of this triangle that theta's from. Cosine of the angle would be the ratio of the length of the adjacent leg, divided by the length of the hypotenuse. And then you have this other trig function called tangent, which has its own ratio. It's the opposite over the adjacent. But really, if you look at it, it's just the sine of the angle over the cosine of the angle. Because if you take a fraction and divide it by a fraction, that's the same as taking a fraction and multiplying it by the other fraction upside down. And so the denominators divide out. Do it in public, good. Great, I'm glad that you didn't listen to anything that I said, and I do not take responsibility. So tangent of theta isn't really its own thing. It's just the ratio of sine and cosine. But I guess the ratio of the adjacent leg over the hypotenuse of the opposite leg over the hypotenuse isn't really its own thing either. It's just a ratio of things. So I guess tangent is as legitimate a thing as sine or cosine is. Mail you the aftermath. Would that even pass through customs? Okay. So this trig identity right here comes from the literal definitions of what sine and cosine are. So if you took any right triangle and you took the sine of an angle from that right triangle, so theta in this case, so it would be y over, not x, but h. H squared, and you added it to the cosine. I'll just put it into a soap bar. Huh. Maybe that would work. I don't know why I'm encouraging you in that. Please don't. So the identity was sine squared theta plus cosine squared theta equals 1. So if you were doing just the literal definitions of sine and cosine, where they're in relation to the ratios of sides of a right triangle, and you simplify the math, so you got yourself a y squared over h squared plus an x squared over h squared equals 1. You have fractions that you can add together and simplify because they have a common denominator. So you can write this as y squared plus x squared all over h squared equals 1. Okay. I already did it, can't help it. Well, poopy. And then you multiply both sides of this equation by an h squared, so you don't have to deal with fractions anymore. Also, I'm just going to swap the order of x and y so it's alphabetical. I've already proven very rigorously that it doesn't matter what order an addition problem comes in, so hopefully you understand that. So, h squared. If you look at this, from the identity, sine squared theta plus cosine squared theta equals 1, from that triangle that I drew, where here's theta, here's y, here's x, here's the right angle, and here's h. Just by moving stuff around, doing basic algebra to our identity, this looks an awful lot like our good friend, the Pythagorean Theorem. Whoop. Plus b squared equals c squared. And that's because the triangle identity in trigonometry, sine squared theta plus cosine squared theta equals 1, is the Pythagorean Theorem. Because the Pythagorean Theorem, it is not sus. It is never imposter. It is always true. Please do not blow the Pythagorean Theorem out of the airlock. That would be very bad. Okay. All you gotta do is just say, okay, these two legs are my A and B, because they're the legs that join together to form your right angle. And the hypotenuse is always your number C. It's fine, it'll survive. And bada bing, your Pythagorean Theorem will give you this. And then just doing the algebra in reverse, you get up to that trig identity. So, long story short, sine squared theta plus cosine squared theta equals 1 is just a fun way of writing the Pythagorean Theorem. That's all it is. The nice thing is, though, the mathematics for trigonometry applies to a heck of a lot more than just literal right triangles. The mathematics that describes triangles and right triangles also describes mathematics for, like, circles. Because if you think about it, if you look back from algebra, the equation for a circle is this. So, if you have yourself a circle centered at 0, that's your x value, that's your y value, and the radius of the circle will be going from the center of the circle to its outer bit. That'd be the radius. So trigonometry, just from this, deals with mathematics of circles, but the mathematics of circles deals with the mathematics of any kind of thing that has a cyclical pattern to it. So, like, the movement of... That's not a very good drawing of a pendulum, whoopsies. So, like, the movement of a pendulum, since it has a cyclical position in time, or, like, the temperature of the outside going from day to day, that's cyclical. So, funny enough, the Pythagorean Theorem, which, you know, originally comes from just analyzing the relationship of the lengths of the sides of right triangles, ends up applying to practically everything. Yep, essentially. I'm smiling, but I turned emotion recognition off because it doesn't really work very well for me. So I just realized I just look like I have my mouth open, and so I stopped. Now, I said I was going to prove why sine squared of theta plus cosine squared theta equals 1. All I did is I just showed that it is really just the Pythagorean theorem. For fun, why don't we prove the Pythagorean theorem then? Hopefully this won't take very long. We know you're... I only pretend to be smart on TV. I'm good at regurgitating stuff that I've learned. But, like, learning new stuff? At least to me, I feel like I'm an idiot. But, I mean, that's, I guess, the nice thing, is, like, if you think that I look awesome, then you can also become awesome, too. Because I am not a genius. But yeah. So, we got ourselves a straight line here. This is where we have to start when we're talking about the Pythagorean theorem. There are some base-like axioms that we have to say about straight lines. Number one, no matter what point you select on a straight line, the amount of distance traveled up and right, or down and right, whatever, is the same as in the reverse, going down and left. I.e., a line never changes its direction. No matter where you are on the line will always point the same way. And it'll do that in forward and reverse. Another thing is that with an infinitely long line, zooming in on your line will just give you another infinitely long-looking line that looks exactly the same as the macro-sized thing. So it doesn't matter how much you zoom in or zoom out on a line, it'll always look the same. The next thing that we're going to have to say is that if you have two lines that are intersecting each other, then they create angles between them. So, like, if you nailed a stick right here at the intersection point of these lines, and then originally pointed it in the direction of this first line, and then rotated it so that it was now pointing in this direction, an angle would be the measure of how much you had to rotate something. Now, one big thing is that lines are pretty much the same going in one way or the other. So this intersecting region is actually the exact same as this intersecting region. This angle is the same as this angle. So that's vertical angles. And guess what? This angle over here, so if we called it alpha or whatever, is the same as this angle over here. Because lines are the same going one way or the other. Let's see. So that's vertical angles. Another thing that we're going to have to say is that the measure of rotation... I didn't want the pencil, I wanted this. There we go. To rotate from facing one way on a line to the complete opposite direction is called 180 degrees. We're just going to say that that rotation from pointing one way in a line to the other is 180 degrees. And that also, another way to measure that rotation is saying 2 pi radians. Another thing is that we're going to assert that angles can add together to create a bigger angle. And if you look, the amount of rotation to move us from this line facing this way to over here is theta, and then we have more rotation to go. That's alpha. But if we add those two rotations together, we get one mega rotation that goes all the way around. This is called supplementary angles. When two angles add together to get you 180 degrees. Oh, and it's not 2 pi radians. That was me being stupid. It's just pi radians. Or pi radians. Another thing is that half of a full rotation is called a right angle, and if you have a partial rotation and then added with another partial rotation, so, you know, a beta and a gamma angle, and you add those two angles together and you get 90 degrees or pi over 2, these are called complementary angles. So, some definition stuff out of the way. Boom. Let's take two angles that are parallel. So, I realize I didn't really explain what parallel was. Parallel just means that two lines are never going to hit each other. Ever. So if you drew, like, a perpendicular line... Whoops. Between them, the distance between these two lines the perpendicular distance, so I guess I should define what perpendicular distance is. Perpendicular means 90-degree angle to. So if two lines are parallel, then the perpendicular line that connects them is the same throughout the entire length of these two lines. This orange line's length will never change as long as it's perpendicular to both. And it doesn't matter where on the lines we look. So parallel lines, they're always the same distance apart, they never touch, and they're always pointing in the same direction. Let's take a set of parallel lines. And cut them with a third line. That's not what I wanted. And I might as well use a different color while I'm at it. Let's cut them with a third line. We have an angle here. I didn't want to write in green. Here we go. We have an angle here. And by vertical angles, we know that that's the same as the angle over here. Because we know that going one direction on a line or going the other direction on a line is still essentially pointing in the same direction. The line doesn't bend or move. So this shape and this shape are exactly the same. And also by vertical angles, this angle and this angle are exactly the same. And if I give these guys names, so if I call this one theta, and I call this one phi, if you look, you can tell that theta plus phi equals 180 degrees, or pi radians, so because they are supplementary angles. Together they make a complete 180 degree rotation on a line. So we know this, so it equals pi, or 180 degrees. Here's another really, really, really important thing. We can't tell the difference between this region and this region. Because parallel lines are essentially identical to each other. And they're being hit by the same third line. So if I covered up one of these lines, and I said, well, which intersection are you looking at, the top one or the bottom one, you wouldn't be able to tell me. There's literally no difference. So, this would also be the angle phi. Actually, it's psi, I think. Yeah, psi. And by vertical angles, that would also be psi. And then this one would also be theta. And so would this. And so now we get really interesting stuff. The inner bits of parallel lines being intersected by the same third line are the same length. If they're on opposite sides of that third line. If you're on the same sides of a third line, then you are now supplementary. If you add this angle and this angle together, you get 180 degrees. Same for if you add this one and this one together, 180 degrees. Outer angles are also the same like this, as long as they're on the opposite sides. and outer angles on the same side add up to give you 180 degrees. So I believe this is called the parallel line theorem. Or parallel axis theorem, I don't remember. But it's like a really fundamental thing. No, don't save. The next thing that we need to prove is... well, shoot. I don't even know if it's an actual proof or if it's just an axiom or whatever. But for any triangle, if you add up their angles together, so alpha, beta, and gamma, you get 180 degrees. Or pi radians. Yeah. And I think we can actually prove that statement. So if I extend this line out, like that... I didn't want to do that. There we go. And I extend this line out, like so. Alright. I can drop a perpendicular line from the extended green line down to the red line, like that. Okay. Because of supplementary angles, we know that this angle right here is going to be pi minus gamma, or 180 degrees minus whatever angle measurement that is. And also from supplementary angles, we know that this angle right here is going to be pi minus alpha. Huh. I'm trying to prove this using the parallel axis theorem. So let's draw the extended bottom red line, but cutting through here and touching the top of our actual black triangle. Okay. I'm going to extend this black line right here, so up like that, and then it keeps going on the under part as well. Okay. We can tell that this whole angle right here is the same as this whole angle right here from our parallel line theorem. And we know that our gray-blue angle is pi minus gamma in length. So then this extra bit would be the pi minus gamma bit minus this bit. So this would be pi minus gamma minus alpha. And then, again, through vertical angles, this angle measurement is the same as this angle measurement. So we know that this corner up here is also this. So pi minus gamma minus alpha. Because of the definition of parallel lines, because I said that I was just drawing this bottom line parallel to this top line, that if this is a right angle right here, then this is going to be a right angle right here. And then that means that's a right angle right there. Okay. Aha! Okay. Another interesting thing. This right here is just one straight line. And I know two of its bits of full rotation, right here and right there. But I haven't figured out what this amount is yet. So I can just say, well, pi equals the alpha angle plus the pi minus alpha angle Oh, yeah, here we go. It's pi minus alpha minus gamma. I'm missing that. Plus some missing value. We'll call it x. These alphas will subtract out. These pi's will subtract out. And if we add gamma to both sides, we end up with x equals gamma. So our missing length here, the missing angle measurement, is indeed gamma. So right here is gamma. And then by vertical angles, that means that this bit right here is gamma. And we know this bit is alpha because this bit is alpha. Let's see here. Ah. I think what I need to do is recopy this top bit. Control copy. The reason why I'm doing all of this, Control paste, is because I realized that I had never proven that when you add the interior angles of a triangle, you get 180 degrees. Like, I had never proved that. That was something that I've just been going off on faith for. So, well, now we're proving it. So if I make this diagram a little bit nicer, so just kind of redrawing it, not perfectly, but like good enough. Kind of like that. And then above this intersection point, I also made a green line. And I also had this purple line that was cutting through kind of like this. Kind of. Yeah, that looks a little bit better. And then move it so that it's actually intersecting right there. Good. So I had that. And part of this was a bit of our original triangle, so I'll put that there. And then the last bit that I'm missing is this one. That goes down like that. Okay. So I figured out that that was a right angle right there. I mean, so is this and this and this. I figured out that this angle was gamma, which means this angle is also gamma. I figured out that this angle is alpha right there, which means this is also alpha. I figured out that this is pi minus alpha minus gamma, which means this angle right here is also pi minus alpha minus gamma. Okay. Oh, and I did a really cool thing that I didn't even realize. Huh. The bottom part of our actual original triangle was like this. So with this part connecting right there. And I had said that this angle measurement right here was beta. But this angle line and this line are parallel, because I purposely drew this line to be parallel to this one. And this is the same intersecting line for this top one right here as it is for this bottom one right here. So this line and this line, this angle and this angle are the same length, which means this is beta up here, which means that beta equals pi minus alpha minus gamma. So if I add all of these angles together, I get alpha plus beta plus gamma, and I can substitute out what beta is. So it's alpha plus pi minus alpha minus gamma plus gamma equals the alphas subtract out, and the gammas subtract out, and I get pi. So right there I've just proven that if you add all the interior angles of a triangle together, you get pi, or 180 degrees. So we don't have to take that on faith anymore. That's really cool. Nifty. I like that. And it turns out, I guess I never really needed this blue line, ever. All I needed was to take, say, this line, recopy it up here, and everything would work out. Very cool. I like that. So, don't save. Okay. Another thing that we need to prove is similar shapes or similar triangles. There are shapes that are different sizes, but are really just scale models of each other. Okay. The way that you can tell, let's say I said this was A in length, this was B in length, this was C in length, this was X in length, this was Y in length, this was Z in length. We'll call this angle theta, and we'll call this angle psi, and then we'll say that this and this are the same angles. Similar shapes says ratios of sides of your shapes will be the same. So y over x would be the same as b over a. Now, we could prove that this is true. So, if I draw a triangle like so, okay, and then I draw a parallel line to that bottom line, like so. So this line and this line are parallel. By the parallel line theorem, we know that this angle and this angle are the same. We know that this angle and this angle are the same. I will name the intersecting points of all these lines. So this point I'll call A, this one I'll call B, this one I'll call C, D, and E. Okay. I'll name these angles, so I'll call this guy alpha, which means this is also alpha. I'll name this guy beta, which means this is also beta. And then I'll name this angle up here gamma. I'm going to call the distance from A to B x, from A to E y, from A all the way down to D little z, and then from A down to little c, not little c, big C. Oh, call it U, and then this distance from C to D I'll call W. My thinking parts died. Yep, thinking parts are dead. Come back to me, brain. Oh, I never even gave this distance a name. Called L. If this whole ratio of sides thing is true about similar shapes, then if I did like x over u, that would equal L over W. So x over u would equal L over W. Or x over u would equal y over z. And then transit property would say that, well, over W equals y over z. This is not how you prove similar shapes. What if I used a parallelogram? Yeah, maybe that'll work. Okay, I don't want to use this triangle because I don't want something that's obviously... Okay, so... Here's a line. I'm going to make another line exactly as long and pointing in the same direction. But then I'm going to move it. I guess over like that. And then I'm just going to connect the ends. Oop. And then I'm going to cut a diagonal through them. One like so. And another diagonal. Like this. Okay. Huh. Since I drew a parallelogram, I know that this angle, this line, is parallel to this line. And I know that this line is parallel to this line. I now know that this angle and this angle are the same from the parallel line theorem. And I know that this angle and this angle are the same. I know that this angle and this angle are the same, again from the parallel line theorem, and I know that this angle and this angle are the same. Two more things that I know. I know that this angle and this angle are the same. And it's the same for these two guys. I'm now going to name these angles. I'll call this one alpha. I'll call this one beta. And I will call this one gamma. And this is all a triangle. I'll call this corner A, this corner B, and I will call this intersection point here C. So then these other two intersection points I'll call D and E, like so. I'm going to name this angle right here theta. So a couple things. I know that alpha plus beta plus gamma, since they're all the interior angles of the triangle ABC. When I add them together, I will get pi radians or 180 degrees. What else do I know? From the green line, I know that angles theta plus gamma also equal pi. And now I have a transitive property that I can work with. So I can throw these two equations together. I get alpha plus beta plus gamma equals theta plus gamma. And my gammas will subtract out, and now I know that my theta is actually just alpha plus beta. So you were just alpha plus beta. Good to know. I guess I can't help but give angle measurements to these other things. Call this angle psi, or phi, or phi, I don't remember. And then this light purple angle I'll call nu. So the Greek letter nu looks kind of like a V. And now I have some more equations that I can fill in. I know that nu plus the angle alpha plus beta plus phi is pi. And I know that from triangle ACD. From triangle ABD, I know that if I take beta plus alpha plus phi plus nu, I get pi. Okay, so these two guys don't really tell me anything new. Although, whoops, don't do that. That's nu right there. This is phi right here. And right here is alpha plus beta. Oh. Well, this triangle and this triangle are the same ones. So, of course. Well, poop. I can't believe I actually forgot how to prove similar triangles. How did I pull that off? Do I use a rectangle to prove it? I think maybe I do need to use a rectangle. Alright. So putting in the diagonals of a rectangle. Labeling the corners A, B, C, D, E. We know these corners are the same. We know these corners are the same. So I'm calling this right here angle alpha, and I'm calling this angle right here angle beta. Because I have drawn this as a rectangle, I know that every corner is a right angle. And I don't really need to write down that they are right angles, but I'm just going to do it because. And I also know that it's a parallelogram as well, so these lines are parallel. Which is how I was able to write down some of the stuff I already did. So if this angle right here is alpha, then I know that this is a complementary angle, because it makes a right angle, so it's pi over 2 minus alpha right there. This angle right here would be pi over 2 minus beta. And we can figure out what this angle is right here, because adding the interior angles of a triangle together get you 180 degrees. So our mysterious angle that we don't know, plus, and I'll go ahead and label mysterious angle that I don't know, pi over 2 minus alpha plus angle beta should equal pi. So then subtract pi over 2 for both sides, add alpha to both sides, and take away beta from both sides. Gives me the measure of the angle that I don't know as pi over 2 plus alpha minus beta. So then I can now put down this angle's name. So pi over 2 plus alpha minus beta, which is this guy's measure, but that's also that guy's measure, right there. By supplementary angles, I know that this bit right here has to add with pi over 2 plus alpha minus beta to get me pi. So this bit is going to be pi minus alpha, well, it's pi over 2 minus alpha plus beta for right here and here. Oh. I think I just figured out how to prove simpler triangles. I'm being dumb. You write down one Big Daddy triangle. Doesn't necessarily matter what it looks like. And then you give yourself a line that's parallel to it. And you hook it up like so. So you got another triangle that you're looking at, and then you give another line. Okay. I'm just going to call this point A, this make a point B, this make a point C. This angle right here I'll call alpha. And since I know these three lines are all parallel, I know that this angle, and this angle are all the same measurement. So I will name them all beta. So this is angle beta, which means this is also angle beta, and this is also angle beta. The same argument goes for these three angles. So I'll call this guy gamma, which means this angle is also gamma, and so is this. I'll give some names to these other points. I'll call this D and E, and I'll call this F and G. So I have three triangles going on. I have the smallest triangle, ADE. I have the middle triangle, AFG. And then I have the biggest triangle, ABC. Okay. I'm going to label the distances between these points on the sides of the triangle. So from A to D, I'll call little x. D to F, I'll call little y. F to B, I'll call little z. A to E, I'll call little a. E to G, I'll call little b. G to C, little c. And then from B to C, I'll just call it L for its measurement. And I think the way that I'm going to prove this is by well, it has to be making a prediction. So I guess I'll make a prediction going from angle ADE to triangle AFG. So from ADE, oh. I just realized I'm missing distances from D to E and F to G. So I'll call this H from F to G. And from D to E, I'll call lil f. Okay, so if I said something like x over a, that would also equal x plus y over a plus b. So if we assume this, then I should be able to... okay, I get it. So I'm assuming... I feel like this is still wrong. Yeah. I'll assume that the smallest and the biggest are similar first, and then see if I can use that to prove that the smallest and the medium one are similar. So I assume x over a equals x plus y plus z all over a plus b plus c. So I have that. And I also have, I could say x over f would equal x plus y plus z all over L. Okay. So I can use these, and then I can say does that imply that, say, x over a equals, so x plus b over, not x plus b, x plus y. You diggling. You silly sod. You goof. A plus b. So then, triangle ADE is similar to triangle AFG. So, let's just take this ratio. X over A I know it is x plus y plus z all over a plus b plus c. I know this. Maybe I need to use, yeah. Yeah. So this one is going to be a monster to try to prove. But I can use a slightly easier one. Does this prove that x over f equals x plus y all over g? So is this true? So we know that x over f is x plus y plus z all over h. I'm gonna have to come back to this. Great. I forgot how to prove similar triangles. And I feel like it's one of the easier ones, and yet for some reason it's just completely leaving my brain. Well, I'm not going to keep trying to kick a dead horse. So we're going to pause math talking here, because I've already been talking for like 2 hours. And we'll go ahead and move on to like actual video games. As long as nobody has any questions. And I don't think anybody's here, so that's fine. So, I'm going to use the restroom real quick. I will be back, though. And when we get back, we'll start playing Silent Hill and roaming around creepy hospital with nothing but a chainsaw. So, I'll be back. I'm back. Well, subtraction and now scale models have kicked my butt. So let's have zombie nurses kick my butt now too. Oh wait, no, 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 don't do that. Don't, don't. Okay. I moved my hair and it made my whole model look like I electrocuted myself. Lovely. Oh no, I did not turn the volume down. That's gonna hurt. There we go. I think this volume is... Yeah, there we go. It's not gonna, like, rupture your eardrums. So we're in the hospital. Okay, I think I got everything in this room. I don't know if we are gonna leave with Maria or not. Oh! Ah, there's a pit in the way. Okay, am I looking at her? It's so hard to tell if you're looking at them or not, because that kind of determines whether or not you're going to hit them. Okay, is this the first door that I have not tried? Yeah! Fantastic. Do-do-do. Just doing my regular routine of making sure that I cannot go in every door. Uh-oh. Oh.
James. Wait a minute. I'm kind of tired. It's just a hangover.
I don't think hangovers make you cough.
So comfy.
I'm gonna go look for her. For Laura. I'll be back as soon as I can.
I'm just gonna lock you in the scary room. I don't care about her. Ooh, a shower room. Let's go be creepy and... Hey, I did it right! Good! Very good. I was so afraid I was, like, stopped too short. Oh, no, Oh, look at that! This is where we use the fishhook, but I need to get a line to attach to it. Hole is too small. I can't get my hand inside to reach it. Maybe if I had a long, narrow tool of some kind. Well, I have a needle. Wait, what else am I looking at? What is it, James? Okay, it's just the drain. There isn't, like, a consumable. Okay, so just a couple more doors to look at, and then I'm pretty sure I'm going to have to go to the roof. Which I'm not necessarily thrilled about doing. Oh, and I have the exam room key. Look at that. That's to the first floor. I think it's a little late, though, because I've already gotten to the 3rd floor. So... Because I remember the solution to open the door to this wing of the 3rd floor. So I never had to go get the hint. Oops. Alright, so... Oh, wait, no, S1 and S2 I never looked at. I completely understand now, like, when more experienced streamers talk about how their brain kind of shuts off when they're streaming. So, like, puzzles that they could usually solve by themselves, suddenly they can't do. Like, I totally become an idiot once I start streaming. So unless I'm talking about something that I already know, and therefore don't really have to think, I can just turn on, like, a tape recorder. If any of you remember what tape recorders are, holy crap, I'm old. Ah, staircase, yes. Boop-doo. We're gonna go to the roof. Rough. Oh, I don't like this part. At all. Okay. So we got a door over there. Ah, and the camera is telling us, hey, look over there. And I'm like, I don't wanna. Okay. So this is something that I definitely wanted to do after I first did this scene in the first playthrough, just to check to make sure there really was nothing else up on the roof. And it looks like, yeah, there's nothing here. So the devs weren't being jerks and like, oops, you triggered the cutscene, guess you'll never come back to this location ever again. No, you're fine. Huh. Uh-oh. I still feel that should have, like, cut me in half. But I have to settle for being on death's door. Because look at my health, it's so low. Okay. I believe this is just where I'm going to find a puzzle solution. Most of these doors I can't open, except for where the tracks lead. Yep, can't open that door. And there aren't any items in the hall. Yep, so just go here. Okay, and then there's blood splatter on the wall. Wait, I think I see a number down there. Something written on the wall. 8283. That's the last thing I need. 82, 83. Because now I'll be able to open the, box, I think. Okay. Crap. Okay. Here, hold on. Let me get to the scene where I actually have, like, a whiteboard. I don't know that one off the top of my head. But you never really have to remember practically anything. Okay, hold on. Hold on. Are you holding on? Good. If you're holding on, then we're good. Well, don't tell me the ending! I want to rederive it now. So if I say x equals cosecant y, so that means x over 1, and so I have a triangle with a reference angle c. This is cosine upside down. So 1 would be here, x would be here. Pythagorean Theorem tells us this would be 1 minus... No, it would be x squared minus 1. But yeah, I don't think I've seen you in here before. And also, you obviously already know Calc 2, so... What's up? Oh, I thought your name was Big Maul. I think your name is actually Big Maui? Is that right? Which is pretty cool. Nice. I was actually, born kinda close to the Hawaiian island of Maui. I was on Oahu. But I don't remember a doggone thing about Hawaii, so that's my only connection to your name. And I'm also white as heck, so I'm not even, like, I'm full haole, too. Although, with the name of Maui, that comes from, like, pretty much every Polynesian culture, doesn't it? Because he's, like, a legendary figure practically everywhere. Cool. Well, hello. I'm a free math tutor that plays games while there aren't any questions. I just watched Moana. Yeah. That was a good movie. The Rock did a really good job. Matter of fact, I wonder if you could make your life even easier by just going cosine y. So you got x to the negative 1 is cosine y. So then you take the derivative with respect to y on both sides. Boop, boop. So what brings you here on this fine day? Besides, knowing more math than you probably wish you did. So, negative x to the negative 2 is negative sine y. Bloop. Oh, and this is dx dy, because chain rule is there. Oh, sweet. Yeah, I'll get right back into playing it. You just kind of triggered my... Oh, crap, I don't remember this. I need to figure it out. Obsession. That's awesome. So, okay, you know what Silent Hill 2 is, which makes me think that you're not in college anymore? So, I'm gonna take a guess here and say that either you're an engineer or, like, a physicist or a chemist. Am I anywhere close? Or a teacher. You could be a teacher, too. Okay. Why did my brain die? Oh, you're none of those! What the heck? Then pretty far... Dang! Hey, Brenton! How are you doing? Okay, so you're none of those. Why the heck did you take Calc 2? What the heck? Okay, now you're just making me look bad. Taking AP Calc. That's really awesome. I was not at that level when I was in high school, so respect, man. So wait, what do you plan on doing with... You gotta be planning on going to college then. If you're taking, like, an AP class, like AP Calc, like, you have to be going to college. Am I right about that? Okay. Got all that. Electrical engineering. That is a really good field. Haha, field. Electrical. And also, you have a pretty good head start, since you're going into your freshman year already knowing Calc 2. So yeah, you're gonna be okay. And Brandon, oh wait, I already asked you how you're doing, yeah? I mean, I could ask again. But yeah, okay, at least you're doing okay. That's good. Oh, you are not doing okay. Are you dying? That'd be very bad. Oh. Still? Did it hurt yesterday? Because I remember you told me that you usually get fairly nasty headaches on Mondays. Also, I think I said x is... Oh wait, no, cosecant is... Nah, I screwed the whole thing up. I really did. That's weird. It didn't hurt yesterday. I'm sorry that you got I'm sorry you got that headache, though. That sucks. I'm not going to do the whole, like... Well, what else? There's got to be something good going on in your life. It's kind of a thing. No, if you feel crappy, you feel crappy, and it's okay to feel crappy. That's just reality. Yeah, and he asked me the derivative of cosecant. Okay. And really, I'm doing this... Why? What's happening tomorrow? dx of sine of x, -1. I can't believe that I did that. Sine of x, -2. Cosine of x. Yeah, that's it. So it is negative cosecant x hot x. I'm pretty sure. Oh, wait, you said inverse cosecant. Right. Okay. So I was doing it right, but I mixed up cosecant with secant because I'm an idiot. Dude, it's okay. That's it, man. You're done. No college for you, no electrical engineering. But look, no one even uses cosecant inverse anyway. You never know. Also, when you get into actual, like, research work or whatever, or programming, you just use Taylor series expansions to stuff anyway? Because it's like, oh, we don't really care about, like, the x-squared terms. I believe... Yeah, it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial, going on and on forever and ever. I love that one, because it's so bloody easy. Okay, ADHD taking over too strong. Okay, let's actually get this so that I can get back into Silent Hill. So, cosecant y. So... Wait, no, that is y right there. Yeah! Well, I was playing, Silent Hill, and then, Big Maui asked a question, and then I was like... Because he was just kind of testing me. Because he's a hotshot flexing on the boomer that forgot a ton of stuff. Okay, so the opposite leg is 1. Hypotenuse is still x. This is still x squared minus 1. Got it. Good. Moving on. So, d... Really, I could just... Nah, it's easier to do ddx. I mean, ddy. Ddy of this equals dy. Cosecant y. So then I have dx dy is then this whole thing, which is negative sine y, negative 2, cosine y, which is negative, yep, cosecant y, cotangent y, and then dy x so much math I have to leave. I am just about done. Just hang in. No, keep going. Okay. The problem with me is that I have a medical condition on top of ADHD that makes it so that my brain doesn't work when I'm trying to talk. So I need to, like, completely shut up. Okay, let's write out what your actual question was first. Oh. Also, I needed that. Thank you, Brandon. Ah, oh, that's so good. And so I could say that that's dy dx. So then, yes. I did set it up correctly. So, what I really want to find out is what this is, and to just memorize it rather than having to derive it every time. No, it is. But, let's say... I'm usually able to do this a lot quicker when there is no camera and I don't have to talk. And also because my memory is atrocious. Yes. And also, when you actually get into your field, you are not going to remember everything that you need to know. So it just helps to know how to get to what you're supposed to know. Like, I'm pretty sure I have been doing this right. Right. So, cosine x over sine squared x. Let's not try to skip steps. So, I guess I'll just leave it there, because it'll just make my life a little bit easier. Okay, so cosecant x, it's 1 over sine x. I got that. Got the chain rule. Cool. So then I can replace this with negative cosine y over sine squared y is x dy. So then flipping things around is... okay. So negative sine squared y all over cosine y, which is negative sine y tangent y. And this is where actually drawing out a right triangle will be helpful. Yep, here's y. And because my original equation that wow, I have the best handwriting in the world. I should have become a doctor. It's that good. So this right here is the opposite leg. Here's the hypotenuse. Here's the adjacent leg. Okay. So sine of y is going to be 1 on x. So negative 1 on x times, and then tangent will be 1 over the square root of x squared minus 1. Boop. So that is negative. I'll write it as a fraction. X square root x squared minus 1. And again, since my equation was this, cosecant y equals x, I have limitations on what y can... wait. Yes. Y can't be numbers that make sine 0. So from 0 to pi. So 0... well, not equals. So I know a boundary there. And also, yep, that's where you get the absolute value, because I made this just the length of a triangle, and you can't have negative length unless you're actually talking about a triangle on a unit circle, like on a... you know what I mean. Alright, so there we are. Cool. I understand that. Thank you for that refresher, though. That was fun. I hadn't done that in a while. Right now on my channel, I'm trying to reprove undergraduate mathematics, at least through the calculuses. That sounds wrong, but whatever. Starting from essentially scratch, so the Peano axioms on down. So if you're ever interested in that, it's called the axiomatic I think it's called Axiomatic Set Theory of Mathematics, but I don't remember. So, eventually, I will get to proving calculus. But right now, I'm still trying to prove subtraction. Okay, but enough of the math gobbledygook. Oh no, my controller. What am I doing? Okay, here we go. Oh, and to give you a hint as to what ending I'm trying to get. Oh, I'm up for anything. That was a good slap. Welcome to the club. Um, Apparently this is like a perfect fit because this is not the only time that I'm going to be playing a Silent Hill game. I plan to go 1, 2, and 3, getting as many endings and items as I can. Uh, but I'm also going to be trying to prove mathematics from what natural numbers are all the way up through like differential equations and stuff. Oh, yes. Like just a couple years after it came out. And I believe I got every single ending. I don't think I ever accomplished a 10-star run though. Uh but yeah, I played Silent Hill 0 through 3. I watched a friend of mine play Silent Hill 4, and then I refused to touch any other Silent Hill game because they're all garbage. But yeah, so you got me in the middle of just my second playthrough of Silent Hill 2, so I plan on playing it a couple more times. So yeah, welcome to the club. Also, if you ever make a "you're welcome" joke in here, I will, I don't know, projectile vomit. Yeah. Also, you give me hope for the future because a high school student knowing about Silent Hill, yeah, that makes me very happy. Because, like, it's hard to imagine that these games are 20 years old. This is ridiculous. Like, somebody in your position looking back at the Silent Hill games is like me looking back at the original Mario game. Well, not Donkey Kong, but like Mario for the NES. Like, it blows my mind that it's the same distance. So, like, there are entire generations of people that don't even know that much about Silent Hill. So, seeing you being very cultured about it because nothing after 4 exists except for 0, because I kind of like that one. That puts a dumb smile on my face. Also, I'm totally not stalling because this game terrifies me to pieces. Because the older I got, the more wimpy I got. Yeah, isn't there a rumor though that Konami kind of gave up the rights? Or something like that? I don't know. I heard I heard rumor. Again, I don't know this for certain. And I think S14 is where the box is. Uh I believe that Kojima was rumored to still be in works with Sony, and I feel like the volume got higher. Hold on, let me turn it down a little bit more. Okay. But, like, after Kojima made Death Stranding, there was a rumor that he was in the works with Sony to actually make Silent Hills. Or at least whatever version of Silent Hill he wanted to do. I don't know how true that is, but, you know, we could dream. 8, 2, 8, 3. There we go. Okay, now we got the hairs. So we can go to the shower room and get the thing in the drain. Nice. Nope, that's not the shower room. Where is the shower room? Oh, I'm right next to it. So yeah, I haven't given up my hopes for, Kojima, Silent Hill. Just yet. Combine you with you. Wouldn't it? I would miss the feel of the first 3 Silent Hill games, but I think Kojima and Del Toro had a good... Their take on what the game would be, I think, worked. And I would be perfectly fine with it. If the game ends up being kind of like PT. Whee! In a circle. And I completely forgot what I picked up. Where is it? Where... Ah, I got the elevator key. Okay. And I never needed to use that. And also, I should probably heal, because if I get hit once, I'm gonna die. Cool. Huh. So I can backtrack and go to that elevator. But I don't think there's anything on the second floor that I need to do. And I'm not in the other hospital yet. Yeah, so taking the elevator to the first floor I think is what I need to do. Yep. That's the plan. Here we go. And I think this is where the lady that you need to put a ring on her finger pops up in the other hospital. Okay. Oh. Well, there is no basement floor. Oh, wait, no, I'm not going to the basement. I'm going to the first floor. I think I'm high. Even though I'm weird and I've never tried marijuana ever. Or any other kind of, like, recreational drug. Does this door open? Nope. Oh, and Brandon, I hope you're still here, because, like, I actually stopped the math stuff, so... I'm not going to be making your headache worse. I'll just make you really scared. Uh-oh. I haven't gotten the shotgun yet, so... I hope I didn't miss it. More bullets. Thank you. Alright, I guess there's nothing else there. Look at both ways before I cross the street. Uh-oh. Is there really not a monster in here? Okay. Oh! I like how the only sane person in this entire game is this little girl.
Laura?
Huh? You know my name?
Eddie told me.
That big fat
How do you know about Mary?
What's the big deal?
Why can't you just tell me?
You gonna yell at me if I don't?
No, I won't.
I mean, she knows that James killed his wife. Or at least, I think she knows.
I was friends with Mary. We met at the hospital. It was last year.
Or maybe she doesn't know.
You liar! Laura,
Fine, don't believe me.
But last year, Mary was already...
No, she wasn't.
I'm sorry, Laura. Anyway, let's go.
Yeah, kind of a big rip.
We can talk about this later.
Spoilers for a game
Place for a kid.
that's 20 years old, and that I've already played
All sorts
through
of strange things
on
happen.
stream.
I can't believe you haven't even gotten a scratch on you.
Why should I? Wait. There's something I gotta get.
Later, okay?
But it's really important.
What is it?
A letter from Mary.
Huh?
I wanna go get it. Is that okay?
Yes.
Come on, hurry up.
Is it in there?
Oh no.
Yeah, in the back.
Oh no. Oh, this is not good. I don't have the shotgun.
What are you doing, Laura?
It's further back, in the desk.
I remember using the shotgun to finish this fight when I first played through, and I don't have it now.
Laura! What are you doing?
What? Oh no.
Ha ha, I tricked you.
Open
Yeah.
the door, Laura.
But will I be able to go back and get the shotgun, though?
Right?
Or is it gone forever?
Want me to open it? Huh? Do ya? What's the magic word?
Laura?
Okay, I guess I won't open it. I think I'll just leave you like this.
You snotty little brat! Open up!
Why, you...
Laura?
I'm pretty sure I went through all the locker rooms, though. So maybe it's in the exam room. Eehee. Oh no, no. Choke me harder. No. James, I hate you. Ah! Owie. Okay. Oh gosh, no! Oh ho ho! Yep, there's one more. Okay. Oh wow, they do a lot of damage. Okay. James, they were right there! Alright. Reload. 4, 5, 6, 7, 8. Reload. Whoa. That fight is a lot more intense when,
James.
you only have the pistol.
James. James.
Well, that was fun. Alright, where's me chainsaw? James, what are you looking at? Also, that garden is not like what it says on the brochure. Oh. Cool, shotgun shells. Not that I needed them anyway. I'm gonna save, but I'm not gonna save over this. Okay. Nothing else. And I really hope I didn't screw myself. Okay, so just through this door. Through this door, don't freak out. You're fine. Wait, no, that's where I came from. Oops. Okay. This staircase will probably open, and the elevator, I think, it will now work. So let's check the stuff that might not work. Okay, good. Where are we? Okay, that doesn't work. So check the door over here. Oh no, it works. Alright, come here. Oh. Woo. Oh crap, I forgot they get two swipes. Alright, Brandon. Hopefully you'll feel a lot better tomorrow. I hate that. Ow, my eyeball. Ow. Ow. Ah. You ever, like, have your eye just suddenly hurt for no reason? Oh, hi. Please stay dead. Thank you. Oh, it's right in front of my face. Thank you. Alright. Okay, I have not tried exam room 2. And there's no need to. Restroom's probably gonna not work. Okay. I know this day room will work. Okay, thanks, game, making me look like a liar. Cool. Right. I guess I can't get the shotgun until I finish the hospital. Hi! Aaron, how are you? Also, that totally scared me really bad, and now I have to change my pants. Uh, good and bad. I still can't prove why subtraction works, and I forgot how to prove why scale models are a thing. What? No, you totally, like, my pulse raised at least by a beat per minute. Maybe. Let's go to floor 2. Your biggest fear. How close are you? Oh. Whew. Alright, you get 2 swings. Gotcha. Okay, swing again. Thank you. I think there's someone still behind me, and I don't like it. Here you are. Okay, swing twice. Whoop. And... What did you say? No, no. That wasn't fair. So yeah, I kind of rambled around along like an idiot. And then... Bonus swing. Buy 1, get 2 free. Yeah. Well, buy 2, get 1 free. I can read, too! I promise I'm intelligent. Oh. Oh, it's the dry cell battery. Which makes me wonder, has anyone ever not gotten the dry cell battery? I was locked up inside the basement's basement. It was so small and dark, and I was so afraid. What do you use what for? Come here. Thank you. Oh! Well, I'm not gonna say anything then, because then... you'll get to see. Wait, what the heck else did I pick up? I picked up the battery, but there was something else that I picked up. Basement storm key. Okay, that's what I got. Also, which version did you play? I'm pretty sure you said that you beat Silent Hill 2, but was that the PS2 version, or was that the Xbox version? Because I don't remember. But I don't want to spoil things for chat. Ah, the PC version, okay. Gotcha. Which might be the Xbox version, but I don't know. Why? Why are there more of you? You know what? Don't do that! Oh, well, yeah, it's to fix your flashlight. That's what it does. I got scared in chat. Yeah. Stay down. Thank you. I feel sill too. It's okay. Although that's still not how you spell, like, windowsill, is it? A windowsill is C-I-L-L? Or is it SILL? I don't know. Oh well. I can't make fun of anybody that forgot the dry cell battery. Because I forgot the shotgun. Because I'm smart. Who needs English? Exactly! It's the universal language. Like a good way to send out a signal to an alien civilization to let them know that they're not alone in the universe is to send out, like, a sequence of prime numbers. Because that would not occur naturally. Nope. Okay. Now, this day room should work. Alright, good. Blah, blah, blah. Oh, there are no goodies. Okay. Do I even need to interact with the fridge to, like, move the story along? I'll try. Oh, well then, you hope that they didn't receive the signal until, like, thousands of years after you sent it. And everyone's already dead. Or gods. One or the other. Hey. Owl. Wait. Oh yeah, I used the elevator to get to the second floor. Right. Right. I remember things. Dang. Okay, I see one of you. And I got hit. Awesome. I think someone's behind me. Whoop. Yep. Okay, get your swings. Do it. Wait, she only did it twice. 1, 2. Huh. So how is everybody tonight, though? Also, I realized that, like, I'm at 7 p.m., well, 6 p.m. PST, so I can imagine, like, it not being nighttime for everyone else. Ready to get spooked. Well, do I have a treat for you? Also, I can imagine. Okay, all that does is say, hey, put a ring on the angel's finger. What other classes are you taking? Nope. Also, AP Psych. That's interesting. Holy crap, this is your... Like, you said you're a senior, too, so this is, like, it. This is the end of high school for you, isn't it? Wow. Biggest word of advice that I can give is that It's kind of hitting hard. Biggest word of advice that I can give is, even if like you like bomb exams and whatnot, it's not the end of the world. You can still pursue like academic dreams. You know. That usually helps take some of the stress off. Although it's still not fun. That's good. And Maria's not here. Nifty. There are empty medicine bottles here. Is this what Maria was taking? Is Maria sick now too? Maybe? Okay. Where the heck am I? Okay, so that door does not work. Did I try that door? Good. Okay, another gigantic word of advice. When you get into, well, if you plan on going to grad school, start studying for your GRE. So it's like the SAT, but to, like, for grad school. Start studying for that by at least your sophomore year. It'll make life a lot easier. Okay, there isn't a door here. Okie dokie. I will be here. At least till 7 my time. And then I will have to run and get dinner. Oh. Okay. Ha 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 ha! Alright, so there's someone else. Who could... Oh! Who could be this monster that I do see? And... Haha! I have proven victorious. Isn't the math on the GRE like Algebra 1? On the graduate entrance exam? I'd say pre-calculus? It's not super easy, but it's not like, it doesn't go into the calculuses. But you have subject-specific GREs as well. Like, I imagine there's one for electrical engineering. And that's going to cover everything. Like, all undergraduate stuff. And they are beasts. Let's see. Here we are. And also, with your GREs, especially the core, subject-specific ones, you're competing against international students. So, like, students from China, and they usually take their, like, subject-specific GREs to do a PhD program, I think after they get a master's. So they come in knowing a lot more than, like, most American students. So making sure that you get into, like, a good graduate program requires you studying, like, extra hard. And I guess that's it. Just remember my siblings taking it and asking me for help when I was, like, in middle school. Wait, so you have older siblings that have already taken the GRE? Wow. That is a... Wow, that's a big age spread. How many... Well, that's personal information, so I'm not going to ask that. But, yeah, wow, that's interesting. I don't think this will work. Yep, did not work. Also, that is hilarious being, like, the go-to person for information when you're much younger than everyone else. I've been in that situation before. It's hilarious. And then your older siblings just beat the crap out of you. Okay, I've never had that happen. My siblings never did that. Oh, this is the basement's basement. This is where we're going. I remember that noise. What am I looking at? Oh, bullets. Basement squared. Uh, let's see. Or the basement of basement. Shelf here. Red handprints on the shelf. Yes.
James.
Mary?
There you are.
Oh, Maria. It's you. I thought you were... Sorry. Anyway, I'm glad you're alive.
Anyway? What do you mean, anyway? You don't sound very happy to see me. I was almost killed back there. Why didn't you try to save me? All you care about is that dead wife of yours. I've never been so scared in my whole life. You couldn't care less about me, could you?
No, I
Then
just...
stay with me. Don't ever leave me alone. You're supposed to take care of me. So, what about Laura? Did you find her?
Yeah, but... She ran away.
We've got to find her.
What, so she could try to kill me again?
You really seem to care about her. Do you know her?
I've never met her before. I just feel sorry for her. She's all alone. And for some reason, I feel like it's up to me to protect her.
Huh. Well, in the hole we go. And there's a ring. Now is that ring the only thing down here? Hey, I'm a lighthouse. Watch out, dangerous rocks. Okay, I'll stop. That's one ring that I got, though. Not a bunch. One ring to rule them all. And up we go. None of those doors open, so I'm just gonna keep going. Wait, am I on the third floor now? Yes, I think. Never mind, I'm a liar. I guess I will save. Hey, there we go. Hopefully no monsters. Right. So I'm gonna go take the other elevator, because now there are two of us, and we can open that refrigerator. That's not the other refrigerator. No, other elevator. I know how words work. No, I don't. Running into monsters. Oh. Hello. Second floor. No, it's first floor, isn't it? No, it's second. Okay. Going down. Oh, I remember this.
Hi there, everybody! Thanks for tuning in. Welcome to another exciting edition of Trick
Or treat!
Here you either answer the questions correctly and win a great prize, or fail to answer correctly and receive the punishment. All depends on you. And our lucky, or should I say unlucky challenger today is James. James Sunderland! Are you ready to play Trick or Treat? Okay, here's your first question. Merry-go-round, haunted house, roller coaster, Ferris wheel, and teacups. Silent Hill is home to a thrilling amusement park that both children and adults love.
You're not wrong.
What is the name of this amusement park? 1. Fantasyland.
No.
2. Silent Hill Amusement Park.
No.
3. Lakeside Amusement Park.
Yes.
Okay, quickly on to question number 2. Silent Hill witnessed a gruesome murder a few years back. A brother and sister were playing in the road when they were attacked and chopped into pieces with an axe. Torn flesh, smashed bones, splattered blood, and finally... What a terrible tragedy. What a gruesome end to such innocent lives. Now the question. What was the name of the murderer who committed this vile act?
Walter Sullivan.
Walter Sullivan. 2. Scott Fairbanks. 3. Eric Gain.
Also pretty sure Eric Gain is a real murderer.
North of the lake is a deserted old neighborhood called South Vale. From there to Pale Vale, the central resort area northwest of the lake, there's only one road you can take. Just one road, no more. The third and final question is, what is the name of that road? 1. Bachman Road.
No.
2. Rindell Street.
No.
3. Nathan Avenue.
Yes!
Well, that's the last of our questions. Have you got it all figured out?
No.
When you know the answers, head to the storeroom on the 3rd floor to collect your prizes. But be careful if you're wrong. Well then, everybody, thanks for tuning in. See you again sometime. Bye-bye.
What was that?
Tongue-in-cheek, self-aware joke. Yeah, Ed Gein is the guy who, like, dug up graves and made his own skin suit, right? And I think he also killed a couple people. I don't remember exactly, but I think he's the inspiration for Buffalo Bill in Silence of the Lambs. And also a lot of, like, other serial killer people.
You can't open it?
Yeah, Maria, give me a hand here.
Come on. You're supposed to be the big man around here. How's a little girl like me supposed to help?
Yeah, he was
What's this?
a very messed up man.
Not very cute, is it? Here, James. You take it.
Just like you.
Thanks.
Okay. Still no goodies, right? Right. Okay. Oop-a-doop-doop. Do I only need 2 rings to put on the lady's finger? I don't remember. So I have to get to the storeroom on the 3rd floor. I know that for sure. Yeah, so I guess I already have all the rings I need. So where am I right now? 2nd floor, hang a left. 90 degrees. Elevator. Up. There we go. Bing! And... onward and upward. Okay, and it's still eerily quiet. Wow! Was that your first time playing it, like, ever? Because if so, then... respect... I have a lot of respect for, like, you being willing to pick up a game that's, again, 20 years old. And, yeah. That's really cool. Badoo. Here we go. Wait, what else am I looking at? Oh, Maria. She's in here. Nothing useful. Okay, now the box. But never played it, and I'd managed to make it my whole life with... Wow. Well, that's awesome that now you have. Okay, well, now your mission is to play Silent Hill 3, and then play Silent Hill 1. Whee! Okay. No. Well, okay, yes. 4 exists. But I personally never liked 4. Oh, that's awesome! Silent Hill 1 is hilarious. And also still terrifying. Okay. It is... How dare they? It is not... It is a lovely game. I absolutely adore it. It's charming. It wasn't bad as... Yeah, no, it is... Huh? Go away. Oddly enough, the hand art of the painting is actually 3D and sticks out. I personally love Silent Hill 1. Combine. And I mean, the third one. Silent Hill 3, I think, is the best OST. Open the door. Okay. I say okay a lot, I just realized. I think in order of, like, the OSTs, it goes 3, 2, 1. I don't think this door is gonna work. But 2 has. That is true. 2 definitely has some really good tracks. Like, its intro is really good. The Heaven's Night theme I really like. And now for the best part of the entire game. Ah! Maria, you probably need to run. There you go. Come on. Okay. Maria, why are you facing that way? Maria! Okay, I guess I really do need to run. What? I didn't know you could have her die! She dies at the elevator! Okay, so you really do have to run so that she runs and she takes less damage. Got it. Right. I've never had that happen. I just wanted to check and see if I could just walk. And I guess I can't. I don't even know if I did the storeroom thing, did I? Why would you stroll through the... Because he's slow. You know, he's not in a hurry either. And also he has a big pyramid on his head. Like, how is he going to be able to aim? Like, the best he could do is just kind of guess where you are, and then thrust. Right? You smell. Yeah, well, I imagine James doesn't smell that great either. Especially since I think it was confirmed that he like, Mary's body was in the back of his car the whole time. Okay, so I haven't even done the elevator thing. Oh, no. Alright, to the elevator. Okay. So, elevator, second floor. Alright, we're gonna speedrun this. I don't care. And then mid-game you... Yeah, I can see how if you had never played Silent Hill 2, he just looks kind of dorky. Cuz like, he just has a, big pyramid on his head and is slightly muscular. And then you see what he does to the other monsters and you're like, he's disgusting. Okay, I already saw this. Lead ring. Okay, so back up to the third floor. Okay, yes, because I was on the second floor. Got it. Good, good, excellent. So we're gonna run to the storeroom, pick up the shotgun bullets. Okay, got ourselves an angel there. I don't care. Alright, and... crap, where am I? Oh, and I passed the storeroom because I'm... Hey! Predict what area I'm going better. Alright, 313. Oh, goody. Oh, I forgot there's ampoules in here too. Nice. Alright, and... I know what to do now, but I'm gonna save anyway, just so that I don't give everybody a headache, so... And... to the angel we go. And if you like it, then you should have put a ring on it. Combine. Copper ring. Good. Okay, nothing there. And then it's just a straight run to the bottom. Got it. Good. Excellent. Okay, and now time to sprint! Ah, let's go! Crap, I ran into a wall. Ran into a wall again. Oop. Oop. Okay, he stabbed her twice. Oh my gosh, he runs! Oh, I've never seen him run. This is another one of the good tracks. Okay. I'm gonna try the examination room. If I can't get in there, I'm gonna have to replay this whole section again so I can get the shotgun. And I'll do that off stream so that I don't make people go insane. Yep, it's irretrievable. That's... No. Do I even have the exam room key in my inventory anymore? Yeah. Oh well. No. Please, no. Yeah, but it's a shotgun. I like it. It's fun. Uh... Mm. Exactly. Yeah. But it's not the same. Okay, what doors have I not tried yet? Like the complete right-hand side that I just walked away from. Good job, me! So, rotate this way. Back over there. Nope. No. Any of these? No. Stop it! I hate that. Wait. Okay, so there are books here. And books here. He who is not bold enough to be stared at from across the abyss is not bold enough to stare into it himself. The truth can only be learned by marching forward. Follow the map. There's a letter and a wrench. Cool, I remember that. Ah, and that's where you get the box. Gotcha. Scared the crap out of me. Crap, and there's nothing else, is there? Yep, that door doesn't work. And I'm screwed. I guess I could try the door to exam room too. Oh, well, I am actually going to call it here for tonight. Because I have to go grab dinner for family and stuff. So... Trying to figure out what button I want to push first. I guess this one. Whee! But yeah. Thank you, Big Maui, for the follow and coming in. Hopefully I can provide quality streams for here on out. No guarantees, though. And Aaron, always good to see you. Hopefully we can gather together a posse of free online tutors and make this thing happen. Also, everyone else who was here or had dropped by, what's up? With more calc in the future, bring it on. Bring it on. All of it. All of it. Yeah. I really do think we're gonna make this work. I got thumbs up. Even though you can't see them. Cool. But yeah. Everyone, have a good night. Stay safe. Good luck on finals. Good luck on whatever projects you're doing. And I'll see you guys tomorrow. Good night.